Worked example 18, an RLC circuit phasor diagram. An RC circuit has an impedance of R equals 50 ohms and reactance of minus 30 ohms. If the supply voltage is 120 volts, sketch the phasor diagram showing all voltages and supply current. Alright, so for our question 1a here, we basically have a resistor into a capacitor and a AC supply with a resistance of 50 ohms and a capacitive reactance of minus 30 ohms, and the supply voltage is 120 volts. In this instance, we need to calculate our voltages over the resistor and the voltage over the capacitor and the supply current. So we don't actually have the information like we did in the previous worked example. So for that, we actually need to work out our impedance, and then from there we can work out our supply current, and from there our voltage over the resistor and the voltage over the inductor. So let's get started. Z is equal to R squared plus X squared, and in this case that's going to be 50 squared plus negative 30 squared. And again, I'll put the negative into brackets there just to remind myself, and that gives us a total impedance of 58.31 ohms. That allows us to then work out our phase shift theta, and our theta is cos inverse R over Z, which in this case theta becomes cos inverse of 50 over 58.31, and that gives us a phase angle of 30.96 degrees. Our supply current IS is going to be our supply voltage divided by the circuit impedance, and that is 120 divided by 58.31, and that gives us a supply current of 2.06 amps. With all that information, we're now ready to calculate the voltage over the resistor, which is using Ohm's law, our supply current times the resistance, which is 2.06 multiplied by 50, and that gives us a voltage drop over the resistor of 103 volts. Voltage drop over the capacitor is our supply current times the capacitive reactance, so 2.06 multiplied by 30. No, we're not really taking into account the minus in this case, so just ignore the negative here. We just want the voltage, and that gives us a voltage of 61.8 volts. With that information calculated, we're now ready to go ahead and draw the phasor diagram. Just like previously though, I'm going to draw a little sketch to remind myself that I can remember to start with, that will help me remember what the phasor diagram looks like. So that I know that VC should be pointing down the way, I know that VR and I should be along the flat, and that means my supply voltage will have to point somewhere in between these going down the way. So I should end up with a phasor diagram that looks roughly like that. The four phasors that I'm going to draw are my voltage over the resistor, which we calculated as 103 volts, or at an angle of 0 degrees. My voltage over the capacitor, which we calculated as 61.8 at an angle of minus 90 degrees volts. And the reason I know it's minus 90 is this is something you should remember. You should remember that the voltage in a series circuit will lag behind the current, or put another way, in a capacitive circuit like this, the current will lead ahead of the voltage. So that's my voltage over the resistor, voltage over the capacitor. My supply voltage is 120, and that's going to be an angle of 30.96, which we worked out earlier, 30.96 degrees, volts. And lastly, my supply current is going to be the supply current we calculated of 2.06 at an angle of 0 degrees. Again, we're taking the supply current as reference. Just like before, I'm going to pick a scale that I need to get everything to fit onto one page, and then calculate the lengths of my 4 vectors, my 4 phasors, and then plot that onto the page. In the book, I've gone with scale of 1 centimeter equals 10 volts, and 1 centimeter equals 0.5 amps. I've gone ahead and I've calculated the lengths, so 10.3, 6.18, 12 and 4.12 centimeters for my 4 phasors. So now I'm going to go ahead and plot them on a graph. Right, with my axes drawn, I'm going to start by drawing my voltage over the resistor, which is going to be a line of 10.3 centimeters. I'm then going to draw my VC, which is going to be 6.18, going straight down the way. And my supply voltage, again we can use the trick as before. We could either measure it with a protractor and then draw it, or we could draw some faint lines, and where those 2 lines cross is where we were going to draw our VS. And again we can do the same trick, we'll draw it and then measure it to confirm VS. And if we've done this right, our supply voltage should be 12 centimeters long, and that looks pretty good to me. Yeah, pretty much bang on 12 centimeters. Finally, we've got one last one to draw, and that's our supply current, which is going to be 4.12 long, 4.12. Nice.